Okay. Um, Here we are. We are attempting to learn all the important things about machine learning. Um, Essentially from scratch. I know very little Python. Um, and I don't have a computer science degree, so this is gonna be fun. Um, what else? Yeah, we're gonna do this until we basically either work for OpenAI, Google, or somebody, Microsoft, in the high tech AI space, or we're able to blend some sort of machine learning paper that's researched and published and peer reviewed. So yeah, we're gonna do this thing. Basically, just gonna keep going until it leads me somewhere. I'm gonna do it every day until that happens. So yeah, just for reference, I started very little. I just refreshed on some of the basics of Python, and now I'm using Anaconda. I installed Anaconda, um, and that's what I'm going to use all my toolboxes. That's the first thing. Two, I'm following a program off of Udemy um, called Python for Data Science and Machine Learning Bootcamp. Um, so that way we have more structure and are able to actually, go somewhere and keep on a certain pace. Um, and three, I'm gonna try to do projects, of course. If it gets to a point where I even like the projects that I'm doing, I'm just gonna post them. Um, so yeah. What else? Um, that's basically it. Nothing too crazy. Just a regular dude. In the day in the age of AI, try to pick it up and learn it. Anyways, let's get into the video. Oh, I felt like a YouTuber. I'm pretty sure you guys can still see everything. Yeah, yeah, we're good.
First number is going to represent the number of rows, and the second
Yeah, and I already was, like I said before, I already started some a little bit into the videos, but it's not anything substantial or significant. Um, it's literally the barest of bones of introduction to how Python works. But now I'm just starting off on NumPy, so we're still basically in the same place. So yeah.
number in that tuple is going to represent the number of columns. So for instance, if I want 2 rows by 3 columns, I pass in the tuple 2 comma 3, and I get back 2 rows by 3 columns. And this is noted by the brackets. All right, if I want arrays of just pure ones, I can say np.ones, and similarly, I can pass in either a single number for a one-dimensional array or a tuple of dimensions for a two-dimensional matrix. That's ones and zeros. Another really useful built-in function is linspace. And linspace returns evenly spaced numbers over a specified interval. And it's important to not confuse linspace with arrange. Here we can see that arrange basically returns integers out from a start and a stop and a given step size. What linspace is going to do is it's actually going to take in a third argument of the number of points you want. Let me go ahead and show you what I mean by that. I can say np.linspace, and I'm going to pass in a start, a stop, and as a third argument, integers out. Similarly, I can pass in either a single number for a one-dimensional array or a tuple of dimensions for a two-dimensional matrix. That's ones and zeros. Another really useful built-in function is linspace. And linspace returns evenly spaced numbers over a specified interval. And it's important
Hmm.
to not confuse linspace with arrange. Here we can see that
Hmm.
arrange basically returns integers out from a start and a stop and a given step size. What linspace is going to do is it's actually going to take in a third argument of the number of points you want. Let me go ahead and show you what I mean by that. I can say np.linspace, and I'm going to pass in a start, a stop, and as a third argument, I'm going to pass in a number. So let's say I have a start of 0 and a stop of 5. And I want to get 10 evenly spaced points between 0 to 5. I can pass in a third argument 10, and this returns back a one-dimensional vector noted by.
That makes sense. So do a lens space. 0 to 5, 100. Evenly spaced breaks or whatever inside. Run that bad boy. Okay. No. NP. Not no. NP lens space. Yeah. Nice. Very nice. That's an interesting computation. 0, 5, 1, 1, 5. Yeah. Sounds about 5. 25, 30, 35, 40, 45, 50, 55, 60. Nice.
The one set of brackets here of 10 evenly spaced points from 0 to 5. And I can change this third argument to whatever number I want. So if I want 100 evenly spaced points from 0
Oh,
to 5, I can just
beat you
pass
to
that
it.
in, and that returns a much larger one-dimensional array. And keep in mind, even though it looks like this is two-dimensional as far as the way it's being printed out, you can tell it's one-dimensional by the fact that there's only one bracket here in front of the array. When you're dealing with 2 dimensions, you'll see that you have 2 sets of brackets on opening or closing at the ends. 3 dimensions will have 3 brackets, etc. All right, so that's linspace. Again, don't confuse linspace with arrange. Linspace will take in this third argument as the number of points you want. Arrange will take in that argument as the step size you want. Let's go ahead and show how we can create an identity matrix using NumPy. We can say np.eye, and then you just pass in a single digit. An identity matrix, if you're not familiar, is a useful matrix when you're dealing with linear algebra problems, and it's basically just a two-dimensional square matrix, meaning the number of rows is the same as the number of columns,
Mm-hmm.
and you have a diagonal of ones, then
Mm-hmm.
everything else is zeros.
Okay. Linear algebra. To refresh on that. Yeah. Oh man. Man. It's gonna be a little frustrating. But we'll pick up as we go along. Ugh.
And that's the reason it only takes a single digit as an argument, because identity matrix must be square as the output for np.I. Alright, moving along, NumPy also has lots of ways to create arrays of random numbers, and we're going to use that often throughout the course, so let's go ahead and cover a few ways to do that. What you're going to go ahead and do is call np.random dot and then the random method. If you click tab, you'll see that there's actually quite a bit of methods, so we're going to go ahead and show you the most common ones. The first one is rand, R-A-N-D. And this is going to create an array of the given shape you pass in, and it's going to populate it with random samples from a uniform distribution over 0 to 1. And that means if I want just a one-dimensional array of random numbers uniformly distributed from 0 to 1, I can pass in a single digit, and I'll get back that one-dimensional array. If I want this to be two-dimensional, unlike the previous functions we worked with, instead of passing in a tuple, I'll actually just pass in the dimensions as separate arguments. So that means if I want a 5 by 5 matrix of random numbers, I just pass in 5, comma 5 instead of the tuple when working with these random libraries. All right, if we want to return a sample or many samples from the standard normal distribution or a Gaussian distribution, instead of using rand, we can use randn. And that means I can say np.random.randn, and this will return numbers not from a uniform distribution from 0 to 1, but instead from a standard normal distribution centered around 0.
Oh, just in case you guys got confused, I noticed that you can do Shift Enter whenever you can run the cell. So yeah, just doing that.
And that means I can go ahead and pass in 2, and I get 2 random numbers from a standard normal distribution. And later on, we'll see that plotting these out, not in this lecture, but once we get to data visualization, we'll go ahead and show you a nice normal distribution curve or a Gaussian distribution curve. And again, if I want this to be two-dimensional, I can just pass in 2 dimensions. So for a 4 by 4, I say 4, comma 4. And no, I don't pass the tuple here, I just pass in each dimension as a separate argument, and I can see by the set of 2 brackets that this is a 2-dimensional matrix as an output. And the final random method of creating an array we're going to learn about is randint, and that returns random integers from a low to a high number. I'll go ahead and show you what we can do for that. You'll go ahead and say np.random, pass in rand int. You'll pass in, if I go ahead and click Shift Tab here, a low, a high, and then the actual size you want. So for instance, if you just say 1 to 100, you'll get a random integer between 1 and 100. And the low is inclusive and the high is exclusive, meaning 1 has the chance of being selected, but 100 does not. And if you want a particular number of random integers, you can pass them in as a third argument. So if I want 10 random integers from 1 to 100, but not including 100, I can just pass in 10 there, and there are 10 random integers, inclusive on the low end and exclusive on the high end. Okay, let's go ahead and discuss just a few useful attributes and methods of an array. In order to do this, I'm going to go ahead and create 2 new array objects. Let me go ahead and clear this and clear these cells. All right, I'm going to set ARR as my variable, and I will say this is equal to nparrange 25. So if I check what ARR looks like, here's a one-dimensional array of 0 up to 24. And then I'm going to say ranr is np.random, and it's going to be got to put a D there, random integer.
Oh, click. Okay.
From 0 to 50. Let's go ahead and get 10 of those.
10 of
So if I check out what ranr looks like this.
Cool. Do that here. Yeah, man, this day and age, learning AI is necessary at this point in some capacity. I'm just choosing to do so the difficult way, I guess you could say. Simply because I like the learning one. I feel like if I get it intuitively, then being able to apply it over like a grand scale, like ChatGPT, prompt training, and all that, it's just gonna come a lot more intuitively. I don't know if that makes sense. Uh, I could be wrong and wasting my time, but I'm gonna keep going.
You may get different values because it's randomly selected, but you should have just 10 integers there. All right, one of the most useful methods you can use on an array is the reshape method, and that's going to return an array containing the same data with a new shape. That means
Oh,
I can call my array dot and then the reshape method on it, reshape, and I pass in the new
size.
dimensions I want.
Right.
So for
So it's not
example, if I want to reshape that array, remember ARR
5 by 5 because I have 10.
is 25 digits,
Yeah,
0 to 24,
5 by
I can
5.
reshape it as a 5 by 5
Or,
array using reshape and then pass in the number of rows you want and the number of columns. Keep in mind, you'll get an error if you can't fill up that
yeah,
matrix
right.
completely. So for example, if I
That's not
wanted
that large.
5 by 10,
Right. Can't even do that because you don't have 50 values. 25 values. So how many ways can we arrange 25? Well, we can do 5 by 5. We could do 3, 1 by 25, of course. 1 by 25, 2, 3, 3, 6, 9, 7, 10, 10, 12, 3, 4, 4, 12, 5, 5, 5 works. 7, nope. 1, 5, and 25. I think. Yeah, dude, nope. What about 10? 10, we can do 1 and 10, 2 and 5. There you go. Let's do 2 and 5. Let's do a 5 by 2. Shake it up a little bit. Ooh,
I would need 50 elements to do that.
right.
And I'm going to get an error here because the total size of the new array must be unchanged, meaning you need to fill up using only the digits you have or the elements you have. A nice simple way to check this is that the number of rows times the number of columns is equal to the actual number of elements. So 5 times 5 is equal to 25, and I know I have 25 elements in this array. Okay, let's go ahead and show a couple more useful methods for finding max or min values or to find their index location. And we'll go over a lot more operations later on in future lectures, but here are some useful ones for you to know. If we go ahead and check out our random array one more time, again, your numbers may be different, but for the sake of this exercise, that doesn't really matter. If you want to find the max value in your array, you can call the max method off of it. And this will return the maximum value of that array. Similarly, if you want to get the minimum value of your array, you can call the min method off of it.
Cool.
If we take a look at the array one more time, we can actually figure out the location of the max or min values by specifying argmax or argmin. Meaning, if I want to actually know at what index value is this max located at, 49, I can say ran r argmax, and that will return the index location of the max value. So I notice that 49 is located at index 3. So 0, 1, 2, 3, I have 49 there. And again, you can do the same thing with the min value. You can say argmin, and it will return the index location of the minimum value. So 6 is the index location of the minimum value, and the minimum value was 3 in this case. Okay, and quickly, a few more useful methods and attributes. If you ever want to figure out the shape of a vector, you can say r.shape, and it'll return back the shape. Notice here, I get 25, comma, and that's indicating that ARR, that array, was just a one-dimensional vector. If I go ahead and reshape it, so I'm going to say reshape to a 5 by 5, and I'm going to set that equal to r, or ARR. Notice now I have a two-dimensional matrix. If I call .shape off of that, notice I'm not putting parentheses, I'm just calling the attribute off of it. Now it reports back that it's a 5 by 5, so it's two-dimensional now. And the last useful attribute I want to show for now is the data type in this array. If you're ever curious of what data type you have in an array, you can just say ARR and type as an attribute dtype, and it will return the actual data type that's in your array. In this case, it's 32-bit integers. Okay, just as a quick review of everything we've gone over, we've shown you how to create NumPy arrays either by casting a list to a NumPy array or by using one of the built-in functions for NumPy arrays, such as arrange, zeros and ones, linspace, and and also the random generation methods. You call
Interesting.
np.random and then rand_n, or randint, or some of the
It's
other
so
random
popular for
methods.
MATLAB to use
All
inset.
right, and one last hint I want to show you.
I don't know.
If you don't want to have to type in np.random.randint, what you can do is you can say from numpy.random
Okay.
import, and then whatever method or function you wanted to import. So if you wanted to import randint, you could go ahead and do that. And then instead of saying np.random.randint, you can just say randint, and now you have a reference for yourself.
Cool.
There you go. Okay. Again, remember you have the notebook with all the notes in case you want to reference any of.
Makes sense. Yeah, we already went through all these. Great, great job. Thank you. Uh, Indexing goes from 0 to 10. Okay, just click on the kind of actually create one. But okay, it goes from 0 to 10. I can create the root index once you use position. Okay. 2 15 6 5 1 6. Okay. So there's gonna be error and there.
When you're learning, you can say something like use print.
Oops.
Hello everyone, and welcome to the NumPy indexing and selection lecture. In this lecture, we're going to discuss how to select elements or groups of elements from a NumPy array.
Honestly, like this is tough. Above all else, like I'm really curious just to see how far I get in this entire journey or whatever. Um, just see what my learning curve's like. Curve, learning curve is like my ability to actually, pick up information and learn things and all that jazz. Um, should be really fun. I asked it what a tuple is. I asked ChatGPT what a tuple is earlier. Can you guys even see this? You guys can't see my incognito window? What? I'm really dragging it right now. What? That's so fascinating. You can see this at all. Wow. That's good and bad. Okay, I'll deal with it. I'll deal with it. Super, super, super. Okay, let's keep going.
Let's go ahead and jump to the Jupyter Notebook to get started. All right, here we are at the Jupyter Notebook. I've already said import numpy as np, and what I'm going to start off with is by creating a sample array. I'm going to say the variable arr is equal to np.arrange, and I'm just using tab to autocomplete there, and I'm going to go from 0 to 10. And when I say 0 to 10, I mean the actual output. In order to get that output, I'll pass in an 11 up here. So now I have an array of 11 elements that go from 0 to 10. The simplest way to pick out one or some of the elements of an array looks a lot like indexing from a Python list. Basically, you're going to use brackets and slice notation in order to do this. What you go ahead and do is type in the variable name of the array itself, pass in square brackets, and then to get a single value at an index, what you can do is just pass in a number. Meaning if I want the value at index 8, I can pass in 8, and it will return back the value at index 8. In this case, it's actually 8 itself, since I just used arrange to create this array. If I want to get the values in a range, just like a Python list, I can use slice notation, meaning I can say the starting index and the stop index. So if I go ahead and say 1:5, it will start at index 1, which is the number 1, and go all the way up to index 5, which is the number 4, because indexing starts at 0. So to show another example of this, I can say 0:5, and that returns all the values from 0 all the way to index 5. I can also remove the stop point or the start point to go ahead and indicate that I want everything else in the array or everything from the beginning of the array. So for instance, if I want everything up to index 6, instead of specifying the starting parameter as 0, I can just put a colon and then put 6,
Mm.
and it'll return everything up to the start of the array to index 6. So that's the same thing as saying 0:6. But I save a little bit of typing by just putting in the colon itself. Similarly, what I can go ahead and do is say array, and if I want to start at a particular index and grab everything up to the end of the array, I can use the same notation I did in a Python list by using slicing notation with a colon. Something to note when you're using this notation of a number and then a colon is that you're not actually grabbing at index 5 and beyond, you're grabbing everything beyond index 5. Because remember, indexing, as
Right.
far as notation in Python,
Okay,
starts
that's
at 0.
confusing.
So
Got it.
5 here is actually at index
I was about to
6,
say, how does it
meaning
know
this
what to
notation
call?
of 5
Because
colon
now how does it know
says
what variable
grab everything beyond index 5. So
use?
that's going to be 5, 6, 7, 8, 9, 10. Because remember, index 5 is actually here at 4, since indexing starts at 0. Here I've grabbed 5 elements, meaning if I say 5 colon, it grabs everything beyond the 5th index, which occurs at 4. And you can go ahead and review Python list slice notation if you want more information about this colon. But essentially this works exactly the same as it does for a normal Python list. NumPy arrays differ from a normal Python list because of their ability to broadcast. Let me go ahead and show you an example of this. I'm going to take my array and grab elements 0, 5. So that's going to be 0, 1, 2, 3, 4. And then I can set it equal to the number 100. And what that is going to do, it's going to broadcast that value to those first 5 digits to all be 100. I'm going to go ahead and reset the array, and you'll see why in just a second. If I show the array, I'm back to 0, 1, 2, 3 all the way up to 10. And I want to show you an important note on slices of an array. If I go ahead and create a variable called slice underscore of underscore r for array, and I set it equal to a slice of the array, for instance, 0, 6. So let's go ahead and see that slice of the array. Here I have the array 0, 1, 2, 3, 4, 5, basically that first chunk of the half of the array. If I broadcast on this array, meaning I say slice of array, I use a colon, that means I'm grabbing everything in that slice. If I try to broadcast this to be another number, such as 99, that means when I check slice of array, I see a bunch of 99s. But here's where you have to pay careful attention. If I call back the array, it's actually changed 99 not just on the slice, but on the original array I had called to.
Okay.
So you should note how that.
Okay. All right. So in order to get a slice of an array, define slice of array. We're gonna call it array. We're gonna get the last or the first 6 values of the array itself. It's called slice. Now let's redefine slice. Wait a second. So what? Okay, let's just do x, right? X is equal to slice of array colon. What is this? What is this value? What does this return? It returns the entire array itself. It defines or it returns that slice. Okay, so we're gonna delete this then. Cool. So if we say slice of array, this entire slice is now going to equal to 99. Now give me back the slice of array. As I return, all the values are now 99. Now we go back into array itself, check what values are on our list or in our array. The values that were in our original slice of array have now converted to 99, which have then converted the values back into 99 in the original array. Interesting.
Change also occurs in the original array, meaning the data is not copied, it's just a view to the original array. And the reason NumPy does that is to avoid memory issues with very large arrays, meaning NumPy is not going to automatically set copies of arrays. If you actually want a copy and not a reference to the original array, what you can do is actually specifically specify copy. So I can do something like this.
Okay.
I can go ahead and say r underscore copy and use the copy method off of the array
a method. Okay.
To specifically indicate that I want a copy. So if I take a look at my array, it's 99999, etc., and then 678 And if I take a look at my array copy, it's also the same thing. But if I do a change to my array copy, maybe by broadcasting every value to be 100, and I check out array copy, every value is 100, but that original array is still unaffected by that broadcasting the command to 100. Go ahead and review the notes on this if this was a little confusing to you, but the basic premise here is that if you actually grab a slice of the array and set it as a variable without explicitly saying that you want a dot copy of the array, you should keep in mind that you're just viewing a link to the original array, and that changes you do will actually affect that original array. Okay, let's go ahead and talk about indexing a 2D array, otherwise known as a matrix. I'm going to go ahead and clear all the cells here for a second. All right, I just cleared all the cells here. And what we're going to do is go ahead and create a 2D array. I'm going to say np.array, and I'm going to pass in a nested list. So I'm going to say 5, 10, 15, 20, 25, 30, and then finally 35, 40, 45. So I'm going to go ahead and show that to the array. And here I have 3 rows with 3 columns. It's 2-dimensional matrix. Great. All right, there's 2 general formats for grabbing elements from a 2D array or matrix. There's the double bracket format, and then there's the single bracket format with a comma. Let me go ahead and show you the double bracket format, and then I'll show you an example of the single bracket format, which is the format I would recommend to use. But you should know both, just in case you encounter them in the wild. So again, there's my 2D array. Let's say I wanted to grab the digit 5. So that's in the very first, or index 0 row, and in the very first column, index 0. For double bracket notation, I can pass in first the row I want, and then the column I want.
Okay.
So passing in 0, 0 here will return the digit 5, since that's the element in the first row in the first column. What I can do is delete and just do a single set of brackets, and that will index an entire row back. So this will index the entire row of index 0, meaning 5, 10, 15. And if I wanted, let's say, the element 25, well, that's at index 1 for the row, and it's at index 1 for the column. So I can say 1, 1, and this will return 25. What I want you to do is try to see if now you could pause the video and try to grab elements from the array individually using this double bracket notation.
Sure.
All right, let's say we want.
Let's do a quick 2D matrix real quick. Or 2D array, otherwise known as a matrix. Okay. 2D. There are. Can't do that now, can we? I have it back to 2D. Oh boy, I'm a little tired. Sorry. All right. So if we wanted to get 30, right? We literally just say 0 and 2 and the second. Come on. Right. if you want 969, we do 1 and 1 again. And one last time, I'm going to do R. If you wanted like 89, right? We do 1 and 2. There we go. Cool.
I wanted to grab 40 as just one last example.
Of course, it's 0, 1, first row, 0, 1, 0, row 1, row 2, technically 3, but index at 0. 89.
Example, that's at row index 2, and it's at column index 1. So that's 40. That's the double bracket notation. What you should do, however, I would recommend, is using the comma single bracket notation. And basically what that does is it replaces the double set of brackets with just a comma. And you pass in the row, comma, column number.
Okay.
So for instance, let's say I wanted the digit 30. I would pass in index 1, because it's index 1 row, and then it's in the third column, so 0, 1, 2. It's in the index 2 column, and that gives me the 30. And that's the same as just saying, oops, r underscore 2d, and doing it with double brackets. I would recommend that you always use this single bracket with a comma notation, because usually it's less prone to error. Now let's imagine that you didn't want single elements, but actual chunks of this array. For instance, you want submatrices from this matrix. You can use colon for slice notation in order to grab certain sections of the entire 2D array instead of just single elements. I'll go ahead and show you how to do that. I'm going to delete this second cell and show you a couple of examples. Let's say we wanted to grab from the top right corner, meaning I want to say 10, 15, and 25, 30. So this top right corner here is what I want to grab. What I can go ahead and do is use slice notation in order to do this. So I can say grab everything up to row 2, and then grab from column 1 onwards. And that returns 10, 15, 25, 30. Let me go ahead and break this down one more time. As far as the
Okay.
rows we're saying is grab everything but not including rows 0 and 1 as the colon, but then don't include 2. So I'm saying slice to 2. And I'll go ahead and show that. That's just a single command. So if I say colon to 2, that returns these two rows. Row 0. Usually grab subsections of subsections like we did here. All right, let's go ahead and move on to the more important method of selection, which we're going to use much more often in this course, which is conditional selection. I'm going to go ahead and create a new array, just a single dimension array, say np.range, 1, 11, and check out this array. Okay, so for this array, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What I can do is I can take this array and combine it with comparison operators to actually get a full Boolean array out of this. And what I mean by that is if I compare this to a single digit, for instance, ARR bigger than 5, I will get an array of Boolean values. Notice it says d type BOOL. So these are true and false values. And it gives me false wherever that comparison was false, and true wherever that comparison was true. And then I can go ahead and save this as maybe bool underscore array. So if I call bool underscore array now, I get back this Boolean array. Now we can use that to actually do conditional selection, meaning I can pass that in to brackets, and I will only get the results where this Boolean array happened to be true. Let's go ahead and break that down one more time. Getting the array and using a comparison operator on it will actually return a Boolean array, meaning an array of all Boolean values. Then I can use that Boolean array to actually index or conditionally select elements from that original array where this happened to be true. So it only returns instances where that Boolean array was true. And more commonly, instead of splitting this up into 2 steps, you would actually do this all in one step. You would say array, and in brackets inside of the array, you would pass in the conditional statement, such as ARR greater than 5, and that will return the same answer. And this is the sort of syntax notation we're going to be using all the time as far as conditional selection. So for example, let's say we wanted to know all the elements of the array that are less than 3. What I would do is I would say array, brackets, and then say array less than 3. And that'll return all the elements where that is true. And that's the sort of thing we're going to be using a lot in this course, especially when we move on to pandas. This is the sort of notation you should get used to. I know it's a little weird at first to see the variable name inside of itself, but hopefully splitting it up into these two steps makes it clear what's actually going on. You're just passing in a Boolean array of values, and then you're just returning wherever it happens to be true at that index of the original array. All right, that's it for this lecture. What I would recommend doing as far as an exercise for yourself is to create a new 2D array by saying np dot arrange. We'll go ahead and say 50, and then reshape this to be a 5 by 10. Notice I'm just calling a method off of another method, so this is all one array. And then you have this nice 5 by 10 array, so 0 to 40 and then 0 to 9. And I would recommend for you, just as practice for yourself, try to, in your mind, grab chunks, and then see if you can use bracket notation to grab the chunks that you thought of. So for instance, maybe you want to grab here 13, 14, and 23, 24. Let's go ahead and show how we would do that. First, I want to break it up into rows and columns. So 13, 14, that starts at row 0, 1, and then 2. Meaning I want to grab rows 1 through 2. I'm going to go ahead and say 1, and remember, with this sort of slice notation, you need to go one more than you actually need. So I'm saying grab from 1 all the way, but not including index 3. So that should be these two rows. Let's go ahead and confirm that over here by just saying r underscore 2d and grabbing those rows, 1 colon 3. And this is basically working just like normal Python list notation. So here I have index 1 and index 2, up to but not including 3. And then for the columns, since I want 13, 14, and 23, 24, that occurs at index column 3. Oops. And then I want 4, not including 5, so I'll go ahead and put 5 there. And that returns what we were looking for, 13, 14, 23, 24. I would go ahead and encourage you to practice this by setting up this array in your own Jupyter notebook and then just grabbing chunks of this matrix as you see fit. All right, there's a lot more indexing help in the notebook. Don't worry a whole lot if you don't feel 100% comfortable with this. You'll get more practices in the final exercise of the NumPy section. But really, this is just to let you know what NumPy is capable of. We won't do this sort of slicing notation that often in the course using this colon notation. We'll use the conditional selection using comparison operators a lot more. All right, thanks everyone, and I'll see you at the next lecture.
Okay, yeah. The only reason why I'm not showing the actual video that I'm watching itself is because I don't want to rip off content that's like paid for. Uh, yeah, content that like costs money and all that stuff, so I don't want to rip that off. Um, it's been a while, so I'm gonna end it here. Cool stuff. Cool stuff. Let's get back to it tomorrow. So, baby, take your time.